Hey guys, welcome back to another video. In this video, you will learn how to find extrema on a closed interval, such as a to b. This is also known as the candidates test. So, candidates test. And it can be broken down into 5 primary steps. So the first step is to find the derivative to determine the critical numbers. The second step is to set f prime equal to 0 and solve for x. Also determine where f is not differentiable. The third step is to evaluate the function at the critical numbers and the endpoints. The fourth step is the absolute minimum is the smallest y value. The fifth step is that the absolute maximum is the largest y value. If you don't understand these steps currently, just take a moment to copy them down, and later we will do some practice problems and it will all fall together. So take a moment to copy these down. Hey guys, so for our first example problem here, we are asked to find the critical numbers and the absolute extrema on the closed interval of the function of y equals x cubed minus 3x squared on the closed interval of 0 to 4. So if we look back at the steps that we follow from earlier, we see that the first step is to find the derivative of the function. So let's find the derivative. Y equals x cubed minus 3x squared. So that means that y prime, also known as the derivative of y, is equal to 3x squared minus 6x. So the second step now was to find the critical numbers. In order to find the critical numbers, we have to set the y prime equal to 0. So let's do that. 0 equals 3x squared minus 6x. And then if we solve it, we get 0 equals 3x times the quantity of x minus 2. And we get that x is equal to 0 and 2. So these are our critical numbers right here. So I'll draw a box around them. And we'll do a little arrow. Critical numbers. And if you didn't know, on a side note, CN stands for critical number because sometimes in math you'll be writing critical number a lot, and math people normally abbreviate their stuff. So CN stands for critical number if you didn't know. So now that we found the critical numbers, the next part of our problem was asking to find the absolute extrema. So the absolute extrema is just a fancy way of saying the absolute min and maximum. So let's write that in. Absolute min slash maximum. So that's what it means. And in order to find the absolute minimum and maximum, what we have to do is draw a table. So we'll draw a table. We'll draw a table of x and y. And in this table, we have to test the critical numbers and the endpoints of the interval. So let's do that. 0 appears on the critical numbers, so we'll test that first. 0. And then we have to find the y value of 0. So we plug this back into here. So let's do that to the side. Y equals 0 cubed minus 3 0 squared. And this is equal to 0. So we'll set it to 0. And then the next value we have is 2. So 2, and then we plug it into here again. Y is equal to 2 cubed minus 3 times 2 squared. So 2 cubed is equal to 8. And then negative 3 times 2 squared, well, 2 squared is 4, and negative 3 times 4 is just negative 12. So this is equal to 8 minus 12, which is equal to negative 4. And then now we have to test our endpoints of the closed interval. So since 0 was already there, we can skip it because we already tested for it. So now we'll go to 4. So now we'll test for 4. Y is equal to 4 cubed minus 3 times 4 squared. So, if you did not know, this is actually equal to 16. I'm not going to do the math now because I'm sure you guys know how to do it on your own. So, this is equal to 16. Now, what does all of this mean? So, in order to find the absolute minimum, we're looking for the value that has the lowest y value. So in this case, the absolute minimum would be 2 comma negative 4 because negative 4 is the lowest y value and 2 corresponds to it. So in this case, we'll write right here, the minimum is located at 2 comma negative 4. And now what about the maximum? Well, the absolute maximum would be located at the highest y value. So, in order to find the highest y value, we look at our table. There's a 0, there's a negative 4, and there's a 16. Well, negative 4 was already taken, and 16 is obviously greater than 0. So hence, this would be our absolute maximum right here. So, we'll write right here. Maximum is equal to 4 comma 16. So guys, this was our first example problem. Now let's try another example problem. Hey guys, so for our second example problem here, we're asked to find the critical numbers in the absolute extrema on the closed interval of the function of h of t is equal to 1 over t minus 2 on the closed interval of 0, 1. So, if you remember correctly, the first step here would be to find the derivative. So, we'd have to find h prime of t. So, h prime of t is equal to, and then I'm just going to write it down. It is negative 1 over t minus 2 squared. If you didn't know how to get that, I highly suggest you check out the Calculus AB playlist that I will have linked in the description. And in that playlist, you can look at the chain rule / power rule video that I uploaded a few days ago. So, anyways, h prime of t is equal to negative 1 over t minus 2 squared. So, let's set this to 0 in order to find the critical numbers. 0 is equal to negative 1 over t minus 2 squared. However, if we try to multiply t minus 2 squared into 0, it's just going to end up with 0. And 0 is not equal to negative 1. So therefore, there is no solution. Now, you may be thinking that, but wait, a critical number can also be where f prime or h prime of t does not exist, which is true. However, a critical number must be defined. So if you were thinking that t equals 2, because if we plug t equals 2 into here, we get 2 minus 2 squared, which is 0, and negative 1 over 0 is undefined. So that would be true, that is a critical number. However, a critical number must be defined. So if we plug t equals 2 in here, we get negative 1 over 0, which is undefined. So hence, t equals 2 is not a critical number. So let's just get that out of the way. So in this case, there are no critical numbers. So now, what about the absolute extrema part of this? So, there are still the endpoints of the function left. So, let's try to do those now in a table. T h of t. So, if we plug 0 in, we get that h of 0 is equal to 1 over 0 minus 2, which is just 1 over negative 2. So, this is negative 1/2. Now, what about 1? If we plug in 1, we get h of 1 is equal to, and we get 1 over 1 minus 2. And this is 1 over negative 1, which is negative 1. So what we can do here is we put in negative 1. Now remember, we're looking for the absolute extrema, which is also known as the absolute minimum and the absolute maximum. So let's do the absolute minimum first. Or actually, we'll just do the minimum. But just note that this is the absolute minimum. So the absolute minimum is always going to be the point with the lowest y value. So in this case, it's negative 1 is the lowest y value. So the coordinate where the absolute minimum is would be 1 comma negative 1. Now, the absolute maximum is where the highest y value is. And in this case, negative 1/2 is higher than negative 1. So hence, the absolute maximum is found at point 0 comma negative 1/2. So to sum up and review for this, there was no critical numbers because h prime of t could not equal 0. So that was a thing. And also h prime of t also could not exist, or h prime of t could be equal to d and e. However, it would not be a critical number because t equals 2 was undefined. And the minimum was 1 comma negative 1 and the maximum was 0 comma negative 1/2. Hey guys, so for our final practice problem here, we're asked to find the critical numbers and the absolute extrema on the closed interval for the function of h of x is equal to sine of x on the closed interval of 0 to 2 pi. So the first step here is to find the derivative. So in this case, h prime of x is just equal to cosine of x. And then in order to find the critical numbers, we have to set h prime of x equal to 0. And we set it equal to 0, and we get that x is equal to pi over 2 as well as 3 pi over 2 on the accepted interval of 0 to 2 pi. So these are our critical numbers. And if you didn't know how I got these values so fast, it's because I memorized my trigonometric identities. Make sure that you memorize those because they're very important. So now that we have our critical numbers, we have to find our absolute extrema. In order to do that, we can make a table. So if we make a table of x and h of x, we plug in the values now. So let's start with the lowest value here, which in this case is 0. So when x is 0, h of x is equal to 0 as well. Now we'll start with the second lowest value, so pi over 2. Pi over 2. When x is pi over 2, sine of pi over 2 is equal to 1. And then we'll go 3 pi over 2. When x is sine over 2, h of x is equal to negative 1. And when x is equal to 2 pi, h of x is equal to 0 as well. So what does all of this mean? So if we were to look at the absolute extrema, we're trying to find the absolute minimum and the absolute maximum. So if we're looking for the absolute minimum, we look for the lowest value. So in this case, it is 3 pi comma negative 1. So 3 pi over 2 comma negative 1. And if we're looking for the absolute maximum, which we are, it would be equal to the highest y value. So 1 in this case is the highest y value. So the absolute maximum would be pi over 2 comma 1. So in review, in order to find critical numbers, you have to find the derivative first, then you have to set equal to 0 and find the critical numbers that are within your domain. Then in order to find the absolute extrema, you can make a table and test both the endpoints and the critical numbers. And whichever y value is the highest, then that means that is the max. And whichever y value is the lowest means it's the minimum. So if this video helped you, please subscribe and like, and comment down below which topic you would like next. It's very helpful. So I'll see you guys in the next one, and peace out.